So now it's asking us to build a confidence interval for the average amount of coffee in each cup. So we have this list of these different amounts of coffee in each cup, and we're now going to build a confidence interval for what we think that true average poured by the machine is. Now remember, it's supposed to fill 10 ounces in each cup. So we're going to build a confidence interval for what we think the true proportion is. It doesn't indicate what size confidence interval. We'll stick with our normal one of 95%. Don't forget, when you are asked to build a confidence interval, you need to go through all steps of panic. I am going to do this by hand, not using the interval button in my calculator just yet, just to be sure we know how to do this by hand. So the first thing that I need to do is define my parameter. My parameter in this case is mu. I'm trying to estimate mu, the true average amount of coffee dispensed by this machine. So I'm going to write that out. The true average amount of coffee, if it has units, you should indicate your units. This is measured in ounces, dispensed by this machine. That is what we are trying to estimate, okay? Not the average in the sample. We know that number. I can figure it out in my calculator. But the true average dispensed by this machine. My assumptions and my conditions I just did a minute ago. I'm not going to rewrite those again. This is P, this is A. So I'm not going to check those out again. We just did it a few minutes ago. The name of this interval is called a T interval. It's also sometimes called a one sample T interval. You can call it either one. T interval or a one sample T interval, either one. All right, now how do you build this interval? Remember, it's statistic plus or minus critical value times standard deviation. The statistic is in the sample. Remember, the parameter is the true average. The statistic is the sample average. So what I need to know is, what is the average of these 20 cups of coffee? What's the average of these 20 numbers? And I can find that under one variable stats. Stat, calc, one variable stats. I can tell it L1 or it defaults to L1. And that's what I get right there is X bar. X bar is the sample mean. And I'm also going to need to know S right here. That's the sample standard deviation. And this, I know this says sigma. That is not what you think it is, okay? It's not the true population standard deviation. You can just ignore that last line. We don't ever really use it. We want S, okay? In fact, the statistics people wish the TI people would just take this last one off the screen, to be honest with you. All right, so we're going to need to know these two numbers, X bar, the sample mean, and S, the standard deviation. And a confidence interval for mean is statistic plus or minus the critical value times S over the square root of n. So X bar is 9.845. The critical value you need to go find on your T chart. Okay, so I can't show this paper and the T chart on the computer at the same time. So you need to get your T chart out. You need to find 95% confidence across the middle. And you need to scroll up to the degrees of freedom that we are for this problem. And the sample size for this problem was 20. So we're using a T19 interval. So you need to scroll up to 19 on the left, 95 on the right, and hopefully you see that that number is 2.093. That's the critical value that goes with a T19 model and 95% confidence interval. That's going to get multiplied by S. We'll round that off. We'll go 0.1986 over the square root of n, which is 20. And that's how you build a confidence interval. So we'll find both ends. This is not an exponent. Don't get that confused. That's not an exponent on this. That's T19. That's the model we're using. All right, so now I'm going to go to my calculator. I'm just going to type in what I see. I always do the minus one first. 9.845 minus 2.093 times 0.1986 divided by square root of 20. And I can just type all that in at one time. And I get the low end of 9.75. I'm going to recall it, second enter. go change that minus sign to a plus, and get my upper n. And that's what I believe the true, remember we're finding an interval for the true average amount of coffee. So now that's C, my conclusion. I am 95% confident the true average amount of coffee this machine pours is between 9.75 ounces and 9.94 ounces. That's what I feel the true amount of coffee, average amount of coffee this machine fills. According to this sample, that is the estimate we get for the true average amount filled by this machine. Now remember, in a minute we're going to do a test. It's supposed to fill 10 ounces in each cup. So I'm sure you can already lead yourself towards what we're going to say about that. Does it seem to be filling 10 ounces or less? And this interval is telling me less. Because the entire interval is below that 10, I can kind of go ahead and conclude with a fair amount of confidence that it is less than 10 ounces. Now guys, remember, this is obviously less than 10, but is it really that much less than 10? Is it really a big deal? Just because something is significant doesn't mean that it's always really important. You need to think about that in the context of the problem. But for now, this is how you build a confidence interval. This is how the formula you would show if you were doing it by hand. If you're doing it on your calculator, you don't need to show this formula right here, but you absolutely need to name it. I would really like if you did both. All right, because you can just do this on your calculator, and I'll go ahead and show you that now. If you go to stat test, this is called a T interval. So make sure you find T interval, number 8, T interval. Different from proportions, it now is going to ask you for the input. Are you going to input data, or are you going to input stats? Data is when you have the data listed out in one of your lists, and that's what we had here. We had the data in L1. Okay, we had the data in L1. So I'm going to keep it on data, I'm going to keep it on L1, I'm going to tell it to build a 95 confidence interval. And there might be a slight difference because of rounding, because I rounded that standard deviation. But there's the 9.75 and the 9.94 for the two endpoints. And it tells you on your screen your sample standard deviation and your sample mean, your sample standard deviation, and your sample size. If you were to put it on stats, T interval, just so you know what that is. So I press stats. What is on this screen now is it's going to be asking you, and I'm just going to change those numbers because it's defaulting to what it was for the last problem. What it's doing is it's asking you, what is the sample mean? So if I would have just told you the sample mean instead of all the data, you would go to this screen. What is the sample standard deviation? So if I tell you the mean and the standard, that's what they mean by stats. If I tell you the statistics, you go to the stats and you just type them in. If you have the list of the data, you put it on data and you tell the calculator where the list is. So notice when I type in the mean and the standard deviation, I get slightly different. It was slightly different numbers than was before because this standard deviation was rounded, and when I gave it the data, it didn't use the rounded amount. But in essence, we're getting the same two numbers.